This video is about refactoring switch statements. Now let us look at how we can do that. Okay, so over here I am gonna create a simple program for demonstration. So let's create the program in this way. I have a list of string that represents levels of software engineer. Okay, so the level would be trainee. Okay, and then we'll have three more. So we have junior, we have mid-level, we have senior. Okay, so that's good. And then I will do for var level in levels of software engineer. And what I basically want to do over here is I want to print and what I want to print is the salary. So I'm going to calculate the salary for each level. Okay, so how am I going to calculate that? I am going to create a function called calculate salary, and then I need to input the type of, or let's say just level of software engineer. Okay, and the way that computation works is levels of software engineer case trainee. So if I'm a trainee, so I'll just introduce a base salary of 17500. Okay, if I'm a trainee, I'm gonna get the base salary. Okay, so I need what now, like 4 of these, for trainee, for junior, for mid, and for senior. Okay, so for junior it's going to be base salary times 3, mid-level 5, and times 8. Okay, so this is how I'm going to do. Now at the first glance, if you look at this, then my IntelliSense tells me that calculate salary can return null. When will it return null? If this string over here, levels of software engineer, that happens to be anything that is other than these 4 mentioned, which I know it's not going to be because I'm not going to program it that way. I am still required to have a default case. So let me just put in that default case for now. Okay, whenever you see switch statements like this, that is bad. So there's a lot of ways this code can go wrong, and one of the way is let's say someone because this is a string, right? Someone can maybe enter something like an empty string. So if someone enters empty string, then this program will now return base salary, but that might not be what is expected. So how can we refactor this? Okay, so let's just first make this like error proof. Okay, so for that I am gonna do this. I am gonna create an enum. I'll call it level of software engineer, and I'm gonna add in trainee, if I can spell it right, junior, mid, and senior. Okay, so instead of taking a string, now I'm gonna take in a level of software engineer. Does that make sense? So this case statement would now look like level of software engineer dot trainee. That's for junior, that's for mid, that's for senior, and this is junior, this is mid, and this is senior. Now I no longer need to have that default case, and I need to have columns. Okay, so this will make my code less error prone. So again, over here it is levels of software engineer. So instead of doing all of this, I can just simply say it is level of software engineer dot values dot to list. Oops, I cannot do that. So the reason I cannot do it is because this is a list. This should be a list of software engineers. Okay, that is much better now because this is less error prone, but this is still bad because we still have that switch statement. Okay, so one of the principles for clean code is that whenever you see a switch statement, you can actually convert it into polymorphism. Okay, so there are cases when you should convert it to polymorphism. There are cases when it's not like feasible. It's not a good idea to convert to polymorphism. So this is a good idea. Why? Because if you look at the switch statement, what it's doing is it's checking for the level of software engineer. This is not levels, let me name that correctly. This is only supposed to be level. Okay, and it's checking for each software engineer, and it is calculating its salary. Okay, so when the situation is like this is a pattern. Okay, I can convert this into polymorphism. Now let's look at how I would do that. So I am not going to use an enum over here. I am going to use an abstract class. Okay, if I do an abstract class, this is not going to work like an enum anyways. I'm going to remove all of that. So level of software engineer, let's say we'll have a base salary. Okay, and then it will have a function that is known as calculate salary. Makes sense. So I am not gonna define what is calculate salary here. So what I'm gonna do is now all of these enums, right, for the trainee, for junior, for mid, for senior, I'm gonna convert these to classes. Okay, the way I do that is I'm gonna say class trainee. Trainee is a level of software engineer, so I'm gonna say trainee extends level of software engineer. Okay, so the way you calculate salary for a trainee is you're just gonna return the base salary. Okay, base salary is something that is inherited by trainee just because it extends level of software engineer. I will do the same thing over here. Let me copy this, be a bit lazy, and I'm going to do the same thing for a junior. I'm going to do the same thing for mid-level and for senior. Okay, junior, the way it's computed is base salary times 3. This is 5 and this is 8. Okay, so now instead of doing this switch statement, I can convert this to something like this: return level of software engineer dot calculate salary. Okay, now I just need to change this. So instead of having values, because that is just an enum stuff, I'm gonna have level of software engineer. So this is trainee, junior, mid, and senior. Okay, so this is how you convert a switch statement into a polymorphism. Now let me show you how clean this is. And why is this clean? First thing, I am not gonna make the mistake of having, if you look at the start of the code, then I had string. Having classes will make sure that I am not able to have anything that is out of normal. So out of normal in our string case would be an empty string, right? So that is not possible over here. That's the first thing. Second thing is this code does not change. It still reads clean, right? It's just like printing salary. If you wanted to, you could have a variable over here that says salary, and then you could print that salary. Okay, that if you like it this way, you can have it this way, but that does not change the fact that we're trying to calculate salary for each level of software engineer. Now if you look at this function is a bit funny, because instead of having calculate salary, I can just over here come in and say level dot calculate salary, and everything would still remain the same. Okay, this still reads cleanly. Okay, this still reads cleanly, but now what I have done is I have removed that switch statement. If you look at my code over here, there is no switch statement, nor is there any if statements. Okay, so I have completely eradicated switch statement and converted it into a polymorphism. Okay, so this is one of the powers of polymorphism. Again, this is one of the ways you could use polymorphism. Now, how does this work? So if you look at this variable level over here, var is actually level of software engineer. Okay, so if you only look at this, okay, this variable, then the API for this variable will have two things. First thing, it will have the base salary. Let me show it to you. Level dot base salary. If that is something I don't want in the public domain, I can just make it private, but for now I'm not gonna take concerns over it. And it will have calculate salary. Okay, in compile time, look at what's happening in compile time. In compile time, if you look at level of software engineer, so let me actually refactor it one step further by converting everything into a good folder structure. So I'm going to do a model, and I am going to do base. Okay, so let me call it base, and I'm going to do level of software engineer dart. So in level of software engineer dart, I'm just going to clean this code up a little more. Instead of having everything in a single file, I'm gonna take all of this, have it be over here. I could make all of these like classes into its own file, but right now I'm not gonna do that. I'm just gonna grab everything and just put it over here. Okay, so you can see that this file is all about software engineers, right? This file is just the main code. Okay, and here now I need to import it, and everything is still fine. Okay, so look, in compile time, so when I mean compile time, I mean if I just look at the source code, then you'll see this level over here is level of software engineer. If I look at the source code for level of software engineer, then I see that the calculate salary function does not have a definition. Okay, so in compile time, you don't really know what that calculate salary function is going to do. Okay, but when you run this code, then what will happen is in runtime, so let's say this loop is running, right? In the first iteration of the loop, it will give you trainee. Okay, and when you call calculate salary on trainee, then this is the function that gets called. Okay, similarly, if you compute calculate salary on junior in the runtime, this is the function that will execute. Okay, what this does is this does the exact same thing that the switch statement was trying to do, but it's more cleaner. Okay, so this is how you refactor switch statements. Quick ending note here, not all switch statements are supposed to be converted to polymorphism. I'll talk about this more in the upcoming videos.